Related rates question number 12 is about a plane flying with a constant speed of 300 kilometers per hour. That sounds easy, but then they say it passes over a ground radar station. So first let's draw the plane. There's the plane. Here's the radar station. And they are a kilometer apart. Just put 1 for 1 kilometer. And it climbs at an angle of 30 degrees. So that's kind of new, right? It's going like this. And there's an x component to this and a y component to this. I don't think I want to do the dots, but I'll draw it like this. And it says, at what rate is the distance from the plane to the radar station increasing 1 minute later? So 1 minute after the plane crosses this direction, it's going to be where? It's going to be here like this. So what we end up with here is this kind of a triangle like this. And that's some kind of horrible law of cosines thing. I am not doing that. So instead what I want to do, I think, is let's make a triangle. Can I flip this easily? Tell me I can flip this easily. Okay, great. And that's going to be this here, like this. So the hypotenuse is the same. I'll call it D. And big shocker, this will be x and y, because that's just what we're used to conventionally, right? And we need to come up with functions for this because it's passing along over time, and they're asking the distance from the plane to the radar station 1 minute later. So they're asking you to find this length as it's changing. So what they're asking for is a dd dt. And this law of cosines version I wouldn't like to do, but this is just a Pythagorean theorem. But first we have to figure out the function for this. So of course we want to find out what x is at any point in time. You have to write the general rule before you fill in the data. So it's traveling at 300, but it's also a cosine of 30. And y is going to be 300 sine 30. But that's the velocity, so it's times time to get the distance, because you've got to travel velocity for some period of time to get a distance. So that's going to be our formulas for distance. And of course, dx dt and dy dt, you'll just drop the t's off. So let's have a look at this. You know cosine of 30 and sine of 30, I hope, because if you know your trig, going into calculus, you dang well should. This is going to be root 3 over 2, and this is going to be 1/2 of whatever the radius is, which for us is 300 kilometers per hour in this sense. So I hope you remember that. I'm going to even take this away because it shouldn't even be on a piece of paper here. I don't want to offend you. The Pythagorean theorem says a squared plus b squared equals c squared. So that's going to be 300 root 3 over 2 t squared plus 300, that's going to be 1/2 sine of 30 degrees t squared. So if I want to reduce this, that would be 150 rad 3 t squared plus 150 t squared. Now 150 squared is what? 150 times 150 is 22,500. Rad 3 squared is 3 plus 150 t squared. There's only one problem with that. We didn't start at 0y. We started 1 kilometer high. So this is actually wrong. This is going to be 150t plus 1 squared. Don't miss that. And if we want to do squared, well, you know, it might be easiest to FOIL it. Let's do it like this. So that's going to be 150 squared we just did is 22,500 t squared plus 300t plus 1. And that equals d squared. So far we haven't done any calculus. This is all trigonometry and algebra. But we can put some of this together. Of course, these t squareds can go together. That's going to make 90,000 times, yeah, that's 90,000 t squared plus 300t plus 1 equals d squared. I don't want to take a square root. Square roots are hideous. But what I can do is take the derivative right away. So we could say 2d dd dt, and I believe this is what we're looking for, how fast the hypotenuse is expanding, equals, remember this is a chain rule, right? It's not just the power rule because it's a function on the inside here, not just a value or variable that you're taking the derivative of. We're taking the derivative with time. So chain rule, 180,000 t. This feels like a lot, but I won't second guess it yet. Plus 300. Then we can divide by 2. So we should get dd dt, I'll just write it here, is 90,000 t plus 150 divided by the square root of x squared plus y squared. And what is x and y? Right? What's our actual distance? What's d? Let's come up here and have a look. It's this stuff again, right? I think that's right. So we should get 90,000, something like that, t. What was this one? It was 100 and, well, you know what? Maybe I'm writing it out too fast too much here. It's this, right? It's the square root of this, so I can take this. Well, I want to rewrite it so it's not so crazy. It was right here. That's d squared. So we'll say it's the square root of 90,000 t squared plus 300t plus 1. We're fuddling through this together. I'm sorry if it's hard to follow. But now we know t, right? Because t, they tell us, is 1 minute later. So 1 minute is not in hours. 1 minute is a 60th of an hour. So we're going to take this t and this t and this t, and we're going to fill that in. I think that's the best thing to do because we're getting some big numbers. 90,000 divided by 60 for 1 minute is equal to 1,500. And if I add the 150 to that, then I'm going to get 1,650 on top. But you see, I don't put in time until I get to the very end here. I think that's very important. Okay, and 90,000 divided by 60 and divided by 60 again, because it's 1/60th squared, is equal to 25. And that's going to be plus 300 divided by 60. You should be able to do that in your head as 5. It's 30 divided by 6 plus 1. So I think what we're going to end up with here is 1,650 divided by the square root of 31. And if I put that into a calculator, the answer I get here is 296.35 kilometers per hour. So let's see if that makes sense to us. We see that a plane is flying at 300 kilometers per hour, and it's not flying directly straight up, which would be exactly 300 kilometers per hour that it's moving away from this. But at a 30-degree angle of incline here sideways, you're still getting rise and you're still getting distance from x. It's just not going to be quite as strong. So I think 296 actually makes a lot of sense. I'm going to say that this is the answer. And the trick for this was, A, do not fall for this like weird triangle shape here. You don't care about that. You only care about this hypotenuse, which you can make into a right triangle here. Make an equation for distance, which is just velocity times time, 35 miles per hour, 300 sine 30, doesn't matter how complicated it is. Velocity times time gives you distance. Then we draw up the Pythagorean theorem, no matter how crazy the numbers look. Take the derivative. Don't take the square root of the theorem. Don't do power rule and all that. Just do it with d squared. And then plug in the values and trust yourself. Let's do the next problem.